No, the thing about modern production grade LLMs like Gemini 2.5 or 3 is that they don't fail loudly anymore. They fail quietly. Instead of blurting out nonsense, they gradually drift in how they respond, maybe getting a little more abstract or less certain over time. The challenge I'm tackling is how we detect the subtle drift and address it before it becomes a problem for end users. Using Datadog and Google Cloud, I have built a system that catches these key signals early on. So let me walk you through how the flow of how this all works. First, a user sends a prompt to our chat endpoint. That request goes into our Google Run services, which is where the main application is hosted. Next, the service calls the Gemini 2.5 or 3. In this case, it's Gemini 2.5, using the Vertex AI to get the response. Once we get the response goes through our evaluation layer. This evaluation layer basically gives out our confidence score, verbosity, and generates a response. And finally, all this data we collect that goes through all these metrics is sent over to Datadog, where we can monitor trends and set alerts. In case if there is any red marks, we can set alerts and we can identify when LLM starts drifting quietly over time. Let me just show you the demo. It's quite straightforward to deploy this in the Google Cloud. Once you're familiar with setup.ssh and deploy.sh, and given that you're all set with Datadog and Google Cloud APIs. So mine is already hosted in a chat endpoint. So let's just call it and say hi. So there is a score metadata right there. And confidence is around 1. That's the maximum that can get. And hallucination score, usually it is from 0 to 0.1 or 0 to 1. When for now the hallucination threshold is 0.6. It's not point. Why is it 0.6? Because I'm tried making Gemini go above 0.5. It is not crossing above 0.5. So 0.6 is the hallucination factor threshold. And also we get the latency as well. Usually when models hallucinate, they tend to take a lot more time than usual. So yeah, latency is also a factor to detect if the model is hallucinating or not. And also the request as usual. So we'll try setting a baseline of how a model should respond. Let me just ask a simple question. What is the time complexity or of bubble sort, not merge sort? And there is a score right there. And confidence is still 1. Hallucination factor is 0.3 for some reason. Yeah, that and the latency is here. Latency part of my network plays a role. I'll just ignore that. And the response we have it here. And we'll try giving a one more baseline factor as well. Will not max anymore. Last, what is the capital of Japan? I think that's the right question to ask it right now. So, yep, that's an instant response. So you can see as confidence is as usual 1 and the hallucination risk is 0.006, almost 0. It is certain that the answer is right. Why? Because it's a simple question. Yeah, we can try. Okay. Now the goal is to spike those hallucination scores. Well, we'll see how do we spike those hallucination risks. We can do that by prompting something vague or delusional. We'll try with something future specific. Okay, it's a wrong. As you can see, the hallucination risk is again up to 0.33 and latency is around 15,000 milliseconds. And we have the response as well. Now we'll step up the prompt a bit. Yep, my bad. So yeah, uncertainty just confidence just went down and the hallucination factor just shot up to 0.44. Now that we are done with our demo, let me show you the Datadog portal. So yeah, these are metrics. So we track latency, token count, and hallucination factor. So as you can see, the maximum we got here today is 0.44. And the maximum I was able to get while testing this project was zero point 0.5, not more than zero point 0.5. So because Gemini 2.5 Flash is a good model, it's not that easy to make it good.